We're at the first Amazon Picking Challenge and the International Conference of Robotics and Automation in Seattle, Washington.
We're excited about fostering new ties with universities and smaller robotics companies. We think that entering the technology field and getting new innovations rolling in an open environment is important.
We had 28 teams come out here to try to compete in the challenge and have the robots try to pick items out of Amazon bins and see if they can fulfill orders. It's a really big challenge for a robot. It's a full system problem, really. You have to have the perception capabilities to understand what you're looking at and identify it. You have to have the logic to figure out how you should move yourself to grab that thing and move it around. So it really takes sort of the full suite of tools in the robotics world to solve the task. You can't just do one part of it.
The little platypus needs to go in. They've got 5 minutes to do that though, so that's before 13:23.
We got a bunch of people from Amazon Robotics together. There's 3 different teams of judges we have walking around. So we have 1 judge that's there to do the official scoring, to keep track of everything. We have 2 that are stockers, so they go in and they make sure that the shelf is stocked just the right way the team expects. And the judge keeps track of all the time for us and scores off as the robots pick things out of the bins. There's a couple important things for the scoring metric. The first most important one is to just get the right things out of the bins and into the tote that we have there. But then there's a lot of things you can do wrong. There's penalties for damaging things, there's penalties for dropping things and picking the wrong thing. So it's really important to get the right thing delicately and efficiently.
For a human it seems simple actually, right? You have a shelf, you have these 12 bins and you get one object out of every bin. Turns out it's not that easy. Even though you know that there are only 3 objects in each bin and you know which they are, just differentiating between them and knowing where they are and then where you have to put your arm to actually grasp them is actually much more difficult than you would think.
We've been very happy with the crowd turnout. It's been just amazing how many people gather around each contestant as they're going. In fact, it's hard for us to watch sometimes because we can't get close enough.
I think the vibe here is definitely excitement. People are so excited about this challenge and they're really working super hard just to compete. It's looking at a real world problem and it's looking at it in a way that forces teams to innovate and to create interesting new methods to do something that robots really can't do right now.
Okay, we have a successful grab, retreat.
There's been a really wide array of creative solutions. That's been one of the most fun parts. People have come up with whole new robot systems that are designed to interface with our shelf and pick items. We've seen robots that look kind of humanoid and have 2 arms on them, a lot of big suction cups or flexible different grippers. So there's just sort of a wide array of tools that are all trying to achieve the same goal, to match up with our items.
3, 2, 1, go!
It's really cool to be here because we've seen some videos of other teams in the preparations. So some of the teams we recognize, oh, that's that robot that could do this. And it was really cool just discussing with teams how they came up with their design choices and seeing what we've done. We've seen a lot of teams have come up with a vacuum cleaner method, and I think that's going to win.
We have a mobile base on the bottom of Baxter so we can move around. This allows us to use different grippers on each hand and switch back and forth between them. We also use the cameras in each end effector and detect features on the objects to find their location. We're feeling pretty confident. We will be able to pick up several objects. Maybe not the full score, but we should get several.
We were kind of expecting object recognition to be hard because, well, for the last 50 years people were struggling with this in AI and robotics. Well, then we learned this ourselves, that this is actually true.
A lot of the teams have graduate students and undergraduate students, and they all came up with great ideas. Some of the real-world problems have been what have caused issues during their demonstrations. And so it shows exactly how hard this problem is and why it's important to have these kinds of innovations and these challenges.
It's a very interesting experience, and I'm sure we'll do it again if there's an opportunity.
We're just happy that we've been able to present this challenge problem to the robotics community and focus research on an application that might someday have potential industrial applications.
We're on the cutting edge of something huge.
Getting this to run in a real industrial environment, it's still pretty difficult, but we're going to develop the technology further in our lab. If there's another competition next year and we think we have a competitive system, sure, why not?
We plan to continue building those ties with universities. How that will show itself in the future is still to be determined, but we're excited about continuing involving ourselves with the robotics community.